good thing that I test my sound. Or going back to that, since that one video I recorded it, 45 minutes without sound. Because boy, is there many times that the sound just doesn't work. I have to shut the earphones off and turn them back on. Considering the fact that even if they're already off and I turn them on, the microphone's not working. So I gotta turn them off, turn them back on, then everything's fine. So good thing I started that habit again. Okay, just as, still just assuming that they were working. So let's go back to services. Okay. All right. We covered everything in um, wildcard. Matter of fact, I might just leave that there. Okay. Services. We talked about DHCP. Okay. We're not going to talk about SNMP. Okay. Well, okay. That's not really fair. So SNMP is simple network management protocol. Okay. It is a protocol that you will run on your routers. Okay. To send out information to a piece of software like SolarWinds. Okay. All right. And SolarWinds will be able to grab information from your router, okay, as it wants to, or the router will send information to SolarWinds, okay, all right, when it wants to, okay, all right. Now again, if you understood how SNMP works, okay, you got polling and you got sending, but nonetheless, okay, and I think there's another word for the sending part, but again, this is not something we're going in depth with, okay. Know of his existence, okay. If you are starting a new a new network, or if you are bringing SolarWinds or something like that, another management platform into your network, you need to know how to set up SNMP. It's pretty very simple. Okay, it's really just one command. Okay, but that's going to send everything. Okay, um, to your SolarWinds, and it might be too much. So you can get a little bit more granular to it. Logging is a concept which is, remember we talked about the timestamps. Why NTP and time and synchronization of time was very important. Okay, logging. Okay, that's the concept of actually. Let's go into here. Okay, all right. See all that information. Okay. Now, if I turn on my timestamps, now everything has the date and the time with it. Unlike up here, because I had turned it off for bringing it into Notepad. Okay, crucial. Okay, all right. So setting up logging is very simple as well. Okay, but apparently the CSRs already has it set up, so fine. Limiting 10 telnet. Telnet has a way of, like, when we actually create our VTY lines. Okay, you can do this with SSH too. Uh, line VTY. Okay, because the VTY lines. Okay, if you look at transport. Okay, all right, input. Obviously SSH and Telnet. Okay, all right, which is the ones we're talking about. Obviously this will work as well. But if I say access class, okay, now if we go back and take a look at this and say access class, filter connections based on IP access lists. Okay, now that is a description, okay, that makes sense to you. That means I can filter connections, all right, and I can use an access list to do this. This gives you the power of saying, look, the only ones that are allowed to telnet or SSH into my devices, okay, from this particular device, obviously, because every router and switch is its own entity, okay. All right, match on these access lists because obviously the access list is only going to be the network engineers on that team, okay, because you don't want anybody else logging into your routers except the network guys. Make sense? Okay, so that's all we're going to talk about with that. Okay, so one thing we can't. Okay, now you gotta understand. It's not like we're not going to have a video more specific on this, on on logging SNMP, and let me tell you that it's very simple. Okay, just create an access list and apply the access list. Okay, the thing is this. Okay, all right, I can leave these alone for now. Okay, all right, all right, but not, I can't. Okay, I can't, and not to mention the fact, um, and this is a funny thing. I need to have a section here for BGP. Okay, and I think I'm gonna actually end up going to the CCNP course to talk about BGP because I believe that's already been laid out. But again, um, we're gonna talk about that first. Okay, this is something that we cannot avoid because here's the thing: IP addresses are logical; they're not physical. The interface that is used to move the traffic from one logical IP address to another, though, is physical. Okay, but as a physical aspect, okay, we as individuals can set up rules and policies and procedures that our engineers and our operational guys need to follow. Okay, all right, now these are policies. Okay, if I want to create a system or a rule, everyone has to follow it from a perspective of, you know, hey, I'm going to follow this rule because hey, that's the policy. Okay, it's a concept of respect, right? Okay, all right. Matter of fact, it is respect. You're working for the company. This is the policy. Follow the policy. Okay. Not only does it make you compliant as an employee, okay, if that's your thing, and say like I'm not saying that as if I'm trying to rage against the machine and I want you to rebel. That's not why I'm saying that. I'm just saying if you're following a policy because it's a policy, okay, all right, doesn't really always make sense. Sometimes you gotta break rules in order to fix things, okay, all right. And again, that's not something that I'm promoting ever, okay, okay. So when that rule is broken, okay, chaos can happen. You might not know what the chaos is, you may not. So, what I'm getting at is private IP addresses. Okay? Alright? Private IP addresses is the concept of this. Okay? Every device, because remember, in order to communicate, you must have an source IP, destination IP, source MAC, destination MAC. Okay? The MAC addresses are unique based on hardware. They're hard coded into the device of the network card. Okay, but the IP addresses are logically defined. Okay, all right, meaning that someone is typing them in, or they are using some type of service like DHCP to administer. Okay, the IP addresses. All right, now hang on for a second. With that being said, okay, what is the reason for IP addresses? Well, in order for any communication to happen, every IP address needs to be unique. Okay? Now, the internet is not just one big broadcast domain. Okay? All right? Because if that was the case, we would have thousands and multi hundreds of thousands of IP addresses sitting on, okay, a broadcast domain, okay, which would be disastrous. All right, but all right, there are multi thousands. Okay, when I say multi thousands, I'm talking about tens of thousands, most likely. Okay, how do I know? Who knows? Because I have no idea what's in an ISP. But I'm telling you, ISPs have many routers. Okay, because it's not just where they're at here in my location; they're everywhere. Okay, all right, and we're not going to create just one device. Okay, Maryland has their routers. Virginia have their routers. Texas has their routers. California has it. You see what I'm saying? They're everywhere. Okay? All right? But from the scheme of things, the internet, even though it's multiple broadcast domains, the routing is still happening. Okay? And if I send out a route, okay, and more than one IP address in that topology is on a particular device, meaning more than one device has the same IP address, there's a conflict, especially on that broadcast domain. But nonetheless, okay, even if it was on separate broadcast domains, we still got routing to deal with, okay? All right, and one of those devices is going to be chosen as the best path, or it might choose both paths, and one packet goes to this one, and one goes to the wrong one. Okay, all right. It's not about a conflict. It's about, but see, okay. Let me stop right there. It's still a conflict. Okay, because your data is not going to be returned by every packet being sent out. Okay, all right. So here's the thing. The thing is, we got three classes of IP addresses, but the problem is this. First of all, if a customer has an actual router that's connected to my network, which is the internet, okay, what are they going to use behind their router? Because any IP address that they use behind their router, okay, that is on that is the same IP address or subnet that's on the internet. The problem that we're going to have is this, okay? The traffic's never going to go out to the internet at all, okay? Because it's going to choose the shortest path, which is internal. Okay, so we have to set up a series of networks, okay, that we're not going to allow to be routed on the internet. We're going to deny those IP addresses, okay, to be allowed to go into our routing tables as an ISP, and we're going to allow customers, okay, to use those addresses as private IP addresses. Okay, so they can build internally anything they want with the private IPs. Okay, now what happens if the ISP does not block those IP addresses? Okay, well now you have private IP addresses being routed into the internet, into the routing table. It's possible. Okay, all right. Keep in mind every command that I teach you on these devices. Okay, nothing's going to change when you go to work. Okay, it's not like it's not like you learning like an operating system. Okay, like like Microsoft or the and their solution is to create add a new domain controller. Okay, but that's Microsoft's solution. It doesn't mean that's going to be the company's solution. It's a great. That's what I'm trying to tell you. Okay, so if you go in there with balls to the wall saying, "Well, the only way we're going to fix this is do a main, put in a new domain controller," okay, and the company says no, and you saying, "Well, there's no way else I can fix it," fine, okay. Um, Either you're demoted, fired, or we'll find somebody else who will. Okay, I mean that's the reality. Where Cisco, okay, what you learn and what you learn at home, what you go through videos, the commands that you put, dude, it's nothing different. Running OSPF across the internet, okay, from one state to another is pretty much just as fast as it is, okay, as you doing it in your lab at home, okay, all right. Now, of course, you're gonna have more latency and stuff like that, but still, okay, it's not that different. Okay, even if it was 30 seconds longer or 3 minutes or 4 minutes for OSPF to come up, it doesn't really matter. The commands are the same. Nothing changes. Okay, so what you're learning at home, that's why I say the real learning at home, but still, okay, what you learn at home you are you are literally creating a skill set. Okay? Now, do not think you're going to grab 5 routers and 3 switches, okay, for your home lab and lab for a month, okay, and, you got a career for life. It doesn't work that way. I can't tell you how many times I have configured or I have typed in the command router OSPF 1, router EIGRP 100. Okay, I can't tell you that. I've installed router OSPF and EIGRP and BGP thousands of times. Okay, all right. That's how that skill set was built. Success equals what? Time. Okay, and it's not just time. That time in that equation equals a time over a period of time. Okay, all right. So you gotta understand, okay, my preparation for CCNP was 2.5 months, okay, and that wasn't enough because when I got to CCNP, I had to go back and relearn CCNA stuff. My time on CCNP was a year, and we're not talking about a year here and there. It's an everyday thing, okay, all right. Dude, I was hardcore. Okay, I wouldn't wish it on anyone, but at the same time, okay, when I tell you I put my time into it, 40 to 60 hours a week every week. Okay, now I'm not saying that's what you got to do. 20 hours minimum a week, guys. I mean, that's lots of people do this, and in a 2 year period, they're strong. Okay, all right, but it's still even with 40 to 60 hours a week. A CCP took me a year of my time after the CCNA. Okay, all right. So and I'm talking about a year after I had to go back to the CCNA and relearn, and literally I had to go back over and go over my, take a couple months to go back over my CCNA stuff because the faster you learn it, the less time you put into it, the faster you forget it. Okay. So if you are going to a CCNP level and you forgot half your CCNA stuff, if you don't go back to that CCNA stuff, you're just asking for a word of hurt, and you're asking for your CCNP to be longer. Okay, now, okay, so NAT has a purpose, and the purpose is this: I can't advertise my private IP address. Okay, okay, and the Class A, B, and C private IPs are blocked from an ISP perspective. Okay, so second, if my ISP, okay, actually allows that traffic to be routed, okay, it's a mistake. Okay, all right. If someone saw that in the internet's routing table, okay, they should be calling their ISP and saying, "Yo, why we got private IP addresses in your routing table?" Okay, should be, but then again, the chances of someone catching it when the internet is probably 100,000 routes. um, when I say 100,000, actually, let's go take a look because it's a lot more than that. Hold on for a second. It's probably 800,000. Probably 100,000. Yeah. So I mean, so that's what I'm saying. So it's probably a million strong. I think like maybe 15 years ago it was probably 800,000 routes. Okay. So now, with that being said, um, let's go back to here. So the concept of that is this: if I have a source IP of 192.168.1.10, and I need to hit 8.8.8.8. Well, I'm going to send that to my default gateway. Okay? All right? Why? Because that's outside my network. Anytime it's outside my network, default gateway, that's where I'm going to send it because the only way to communicate with something outside my network is to use a router. Okay, so my router is my gateway to get outside my network. So now there's a problem. If the source IP is still remaining at 1.10 and that is sent out, okay, whoever gets that, like 8.8.8.8, okay, they're going to send that information back to the default gateway because the source 1.10 is outside the network, but that router is going to have no clue how to get to 1.10 because everybody is following the rule to block private IP addresses. So we have to have a way of getting our traffic back to us. Okay? So why not change the source IP address of 1.10 and change it to one of the public IP addresses that is live and routable on the internet? And that's what NAT does. That's why we call it network address translation. On this router, we're going to change the source IP address of 1.10 and change it to one of my public IP addresses I have from my ISP. Okay, which is 65.10.10.1, 2, or 3. Doesn't really matter. Okay. So when I get sent out, now the source is 65.10.10.1 and not 192.168.1 to 10. Okay, cool. So what's going to happen? So now when the return traffic comes, the destination is going to be 65.10.10.1, bringing that traffic back to me, okay, and my router. All right, because keep in mind, this router that's doing the NAT translation, okay, is mine. Okay, I'm the one that's going to have to set up NAT. Okay, I need my traffic to come back to me. Now, on that particular router, which is right here, okay, yoink, okay, that router itself, okay, it keeps a translation table. Okay, once it translates the 192.168.1.10 to a public IP address, it keeps it in its table. So the return traffic that comes back, it can translate the destination of 65.10.10.1 back to the original IP address, okay, that was natted in the first place, okay, because of the table that it maintains. So that means we have a way of doing this. Now, instead of having, 100 IP addresses, okay, all right, public IP addresses and costing us money, we can still have this one IP address, okay, and we can use an addendum of the IP address, okay, which will be a port number, okay. So every bit of traffic that goes out and gets translated to that same IP address, we're going to add a random port number to it. That means I can have millions of IP addresses sitting behind that router being translated to one single IP address with random port numbers. Still keeping those port numbers in the translation table. So when the traffic comes back, it's going to utilize the same port number, okay, that I had in the source, okay, and they're going to put that same port number and IP address, by the way, in the destination for the return traffic, which will be me, okay, so whatever that port number is, that will send it to the IP address, okay, or the PC that originated that traffic, all done by the NAT table, okay. So we talked about why we need NAT, okay? All right. And how do we set up NAT? That's another video, okay? All right. So we have a static and we have PAT, which is port address translation, which is what I just explained by using the port numbers. A static NAT is a one-to-one, meaning that, okay, if I create a static NAT, I'm going to say 192.168.1.10 equals 65.10.10.1. That means anybody, not only can I send traffic out and gets translated, but anybody's source from the internet coming in, okay, will be able to hit this PC. Just like that. So you gotta be very careful on what you're statically natting, okay? All right, it's a bi-directional communication. Okay, all right, where Pat is really from the inside to the outside. Okay, all right, and the return traffic is allowed. Okay, but anyone being sourced without static net from the internet, anyone who's sourced from the internet, they're not gonna be able to get in. Okay, so keep that in mind. Okay, the command overload, which we have here. Okay, that's what we use to actually set up PAT translations, meaning that we're overloading the IP addresses on this side to one IP address. Okay, instead of having a pool of IP addresses like we have here, we have three. That means we have purchased three public addresses. But hey, the problem with that is, okay, the problem with that is that means three people only can communicate with those three IP addresses at a time. Once that fourth PC tries to actually pull an IP address out of the pool of three IP addresses that they're already being utilized, that traffic is dropped because the pool is exhausted. So PAT translation or port address translation, which is PAT, that's with overload command. That's probably your best bet. Okay, because I only need one public IP. All right. What happens with two port numbers when two port numbers are the same? That's I don't know why I don't know why that's there. Maybe that was something that I talked about way back in the day. But um, okay. Here's the thing that if they're random, that's not going to happen. Okay, possibility that it could happen, but you got to understand. All right, you're going to understand if it's already in the translating table. I don't. Guys, I've never seen that happen. And if it did happen, okay, um, going through the translating table, for that particular traffic, because I'm going to be attracted to a particular flow of traffic that's not happening. And maybe I can find that they're using the same port numbers, but I could just kill that translation. Okay, that I can actually clear the entire NAT table and let it propagate. Anybody who's in a live session with the flow of traffic will be dropped, but okay, in seconds will come back up with a new session. Okay, or maybe I can do it statically. I've never ran into that in my entire career. Okay, so I don't know why that's there. Okay, maybe I have to look that up and maybe there's some type of Cisco documentation on it um, that I have forgotten, which means that's why I put that in there in the first place. Okay, and we talked about the static MAC one-to-one. Okay, and that's that in a nutshell. Okay, you cannot have private IP addresses. Okay, and not use that. Okay, you just can't do it. Okay, so you got to know how that is. All right, be strong, be determined, be Cisco.